Here we have a SAT math problem. Okay, let's go to the question. 2 over x square positive 3x positive 2 equals to a over x positive 1 positive b over x positive 2. The equation above is always true for all values of x except x equals to negative 1 and x equals to negative 2, where a and b are constants. What is the value of a? Okay, here to solve for a, what we have to do is we have to simplify the stuff on the right side over here. Okay, here we have addition of two rational expressions with different denominators, x positive 1 and x positive 2. Okay, here if I want to add these two expressions, what we need is we need the same denominator. For that, we have to check whether the denominators can be factored over here. So here the two denominators x positive 1 and x positive 2 cannot be factored anymore. So now in this case, what we can do is we can do cross multiplication to add these two rational expressions on the right side. Okay, now let me take the given equation, the left side of the given equation as it is. It is 2 over x square positive 3x positive 2 equals to. Now let me apply cross multiplication to add the two rational expressions. That is numerator a over here has to be multiplied by this denominator. Then I'm getting a times x positive 2. And we can take this addition sign as it is. Let's multiply this numerator by this denominator. Then we get b times x positive 1 divided by. Now we have to multiply the two denominators. Then I'm getting x positive 1 times x positive 2. Okay, here 2 over x square positive 3x positive 2 equals to. Now let's distribute this a to this x and 2. Then I'm getting ax positive 2a, and let's distribute this b to this x and 1. Then I'm getting bx positive. B times 1 is b. Okay, here we can multiply the two binomials over here. X times x is x square, positive x times 2 is positive 2x, and positive 1 times x is positive 1x, and positive 1 times 2 is positive 2. Okay, here we have 2 over x square positive 3x positive 2 equals to, we can write x terms together over here. Then we get ax positive bx positive 2a positive b divided by, okay, x square. Now let's combine the like terms over here. 2x positive x is 3x positive 2. Okay, here on both sides of this equation, we find the same denominator, x square positive 3x positive 2. When I multiply both sides of this equation by the expression x square positive 3x positive 2, this denominator will cancel out. The resulting equation is 2 equals 2. And here we can factor x out from these two terms. Then we get a positive b times x positive 2a positive b. Here on the right side, we have a term which contains x, and this is constant. Since we have a term which contains x on the right side, on the left side also we can write a term which contains x, that is 0x. So we can write this one as 0x positive 2. Now the linear expression we have over here, are equal. Since these two linear expressions are equal, then the coefficients of x must be equal, and also the constant terms must be equal. So the coefficient of x on the left side is 0. The coefficient of x on the right side is a positive b. They must be equal. And the constant on the left side is 2. The constant on the right side is 2a positive b. They must be equal. Okay, now we have to solve for a in the system of two equations over here. So for that, what we can do is we can subtract the first equation over here from this second equation so that we can eliminate b. Okay, now let me write the second equation as it is. That is 2 equals to 2a positive b. Since I subtract this equation from this one, I have to multiply the terms of this equation by negative. So when I multiply this 0 by negative sign, it's still 0. When I multiply this a by negative sign, it will be negative a. When I multiply this positive by negative, it will be negative b. So here positive and negative will cancel out. When I combine this 2 and 0 on the left side, it's 2. When I combine this 2a and negative a on the right side, I'm getting a. Okay, here I got the value of a. It is 2.